So hi folks, thank you so much for coming here to my talk. My talk is specially about why is CI still doing your promotions. By the way, about myself, I am Faika Ansari and I work with Equity as a software engineer. And these are my handles if you want to connect with me. Apart from being a software engineer, I'm also a CNCF ambassador and also one of the maintainers for the project called Kargo and a Kubernetes release team member. So let me start this talk with the foundation of software delivery. Across the years that we've been doing software delivery, we've always been trying to merge PRs, build products, and then run tests, and then package our software, and then deploy it, and then run it on top of virtual machines. That is the very basic foundation of how CI/CD works when it comes to software delivery. But then there is cloud native. Of course, we are at cloud native reject, so we're going to talk about it. There comes containers. So now we are packaging containers and then deploying it into Kubernetes clusters, right? But then at times we need the help of GitOps when things are expanding and we want to scale, right? So that time when we are packaging containers, we use GitOps to pull things from Git, manifest from Git, and then deploy it on a Kubernetes cluster. That's how our traditional CI/CD workflows have been working around for quite some time now. But now, let's explore Kubernetes container delivery's maturity model. So with the help of the Kubernetes controller delivery, continuous delivery maturity model, I want to tell you about the levels of how continuous delivery have been progressing across the years. Very much the first level of Kubernetes continuous delivery is manual delivery. Let's say human-based CI/CD delivery where you use manifest and then deliver it to the production, right? The level 2 that I would be discussing is the CI-based delivery that we've been doing, and then the GitOps delivery where tools like Argo CD and several other comes into picture. And then I will discuss a new tool that will help us remove all these dependency on our CI tool for doing the delivery and separate it from it to do promotion-based delivery and tell you what are the pain points through it and what all things is it solving. So level 1, that is manual delivery, which is a reality for a lot of teams even today who are doing manual delivery, that is deploying manifest manually into Kubernetes clusters. How it works is there is a user who will simply update the manifest in the source code repository. So the manifest is living in the source code repository and then will use kubectl apply or Helm upgrade to just apply those changes in the Kubernetes cluster. That is how manual CD works, right? Now, in this case, you have to track all these manifests along with the app source code, and then developers and operator will need to have access to the source code and also need to have access to apply these kubectl manifest. So this was about manual CD. Now, of course, these has pain points, and that is why we've been evolving from this step. So I'm trying to take this talk from a very ground level, how the CD has been done from since so many years, what are the pain points, and what is still missing in the continuous delivery pipeline, and then talk about promotions, which is basically the theme of this talk today. So the pain point with manual delivery is obviously no continuous reconciliation. There will be no control loop. There will be nothing that will keep an eye on it. You'll always have to do things manually. And whenever the desired state changes, there will have to be someone who needs to apply those changes to make it happen, right? There can be configuration drift, of course, because there is no automation. And then there will be manifest always leaving along with your source code. So these were some of the pain points of the manual delivery, and that's why we came with delivery with CI, right? Now people are using CI to update the manifest. They are also using CI to push these changes to the cluster. And how is it working? There is a CI workflow, and a user is updating the manifest in the GitOps repository. The CI is pulling all this information from the source code repository and then triggering the CI workflows to then apply those changes in the cluster. So that is how CI works with your existing CI/CD model. Now here, the manifest will be stored in a dedicated GitOps repository. That's how CI-based workflows are. Now the users will propose these changes in the form of pull request. This has to be done by the user. Again, now the app code may run CI to update the image tag. So that's again something which has manual dependency. And then you'll use the kubectl apply command to do the same things. There are still pain points with this. There is no continuous reconciliation. You will still have to handle the promotions. Now by promotions, what do I mean? By promotions, we mean versions. Let's say there is version upgrades into your manufacturer. You always have to do it manually, right? There will be CI workflows will need permissions. Now, in this case, you'll have to give right permissions to users, and all these things have to be handled manually. And then these changes are also applied sequentially, so you have to do this in a very sequential manner, which will, of course, take a lot of time. Then we come with the level 3, which is pull-based CD, which is very much the case a lot of the teams are still doing even today, which is very much safe, very much repeatable, very much observable, but there still lies some pain points. So let's see what is this pull-based CD, which of course a lot of teams are still doing. It works with Argo CD. Argo CD being one of the top most CNCF projects out there, where manifests are stored, and Argo CD basically does all the continuous reconciliation. That pain point is handled by Argo CD. How it does that? Let's quickly see it. So there is a user which updates the manifest in the GitOps repository, and then the CI system takes it from the source code. Argo detects these changes automatically with its controller in Git, and then applies those in the cluster. Now this handles the continuous reconciliation part. Now user will propose these changes in pull request, and GitOps controller will run it in the cluster. This is so much more simpler. But this was about Argo CD. Now let's see, this was a GitOps continuous delivery thing. So how is Argo CD helping us? It is helping us reconcile the live state that is there in the production with the desired state that we want, and all of this will be automated. For this, Argo CD uses a lot of key components like repo server, application controller, servers, application sets, using which it is able to achieve this amazing functionality. But there still lies a pain point. What is that? There is a single target continuous delivery. Now, there will be a single target of a manifest that will be applied by Argo CD and will be continuously reconciled to apply it into the cluster. But there is no promotion logic here. It is very difficult to tell what is running exactly where. And of course, there is no support for promotion techniques like progressive delivery, A/B testing. You can't do the A/B testing sort of thing where you deploy your environment into and give it to some section of your customers or things like that. And of course, verification is not handled directly through this promotion mechanism. So if I come back to what a CI/CD expectation looks like, it's not simply building it, testing it, and then deploying it into production. It's a very much of a different loop where you have to build it. It is in the development environment, then you try to test it, and then it gets into staging and then gets into production, right? So the real world CI/CD expectation has to be like this. But is Argo CD actually easily, repeatably able to handle this? Maybe at some point, not. So that's why the CI/CD reality in today's world is very much like this, where a user is trying to change some configurations, it gets into the development environment, we try to build it, and then we try to run the test, it gets into staging, but maybe before getting into production, there are some more canary deployments, there are more hot fixes that happens, and then it again gets back to, let's say, development or staging. And this kind of very much triangular CI/CD workflow causes a lot of configuration drift and a lot of, we could say, time-bound issues for developers and for admins specifically when they have to monitor all of these kind of changes. And also for a fact, a lot of us are missing out on this, is CI and CD is very much different, right? So we have been for a very long period of time using CI, that is continuous integration, to do our deployments now and deliveries. So what do we mean by that? So CI is specifically, what is CI supposed to do? CI is when you are given code, you have to build the artifacts using it, right? That is as simple as that. CI just needs to use the code to build the artifact, whereas CD is supposed to use that artifact and roll it out safely. That's the job of CD. But for a very long period of time, we have been using CI stuff to do the CD things, and it's very much different. You need to get CD rolled out CD is very long-lived because obviously canary deployment and all those kind of things take so much more time than you can expect. And it is very much long-lived. But when it comes to building the artifact, it is very much quicker, and it has a predefined beginning and end. Once the job is done, it is successful. So this is a very clear difference, and that is why to build the gap between CI and CD, we need something called as promotions. And this is another level of the Kubernetes Continuous Delivery Maturity Model, which handles promotions. Now, what does that mean? Now, controllers will be responsible for the changes that are happening in Git. So there will be promotions for multi-stage deployment. I'll come to this point, what do we mean by that? And continuous verification. These needs to be the step that needs to be there when we talk about promotions and deploying CD. Sorry, going through the CD. How does that work? So now we came up with this concept called as continuous promotion, and this is very much for a GitOps cloud native friendly way. There needs to be a CI system, which is basically the place where we are building the artifacts. Then there needs to be a continuous promotion system, which is detecting those changes and orchestrating all those changes so that the CD process can handle that by GitOps. That is basically the actual proposition of this talk, that we possibly need a continuous promotion model so that we can have this mid-tier to keep doing the CI stuff and separately doing the CD stuff without merging both of these tasks. And that is where we have the essence of this talk. We have a project called Kargo, which is very much open sourced. And the aim of this particular project is to provide a declarative way for you to promote your applications in the GitOps environment, which will also enable continuous promotions across all these environments. So now this declarative, so now like, there was Kubernetes, right? At first place, why was Kubernetes even there? That was a very declarative way of managing your entire infrastructure. Then there came Argo CD, which was a very declarative way of managing your deployments into the cluster. And now comes Kargo, which is again a declarative way which slots in there so that it can orchestrate all these releases that goes around with your promotions that goes around and all the version artifacts for your source code. So that is where Kargo is into the picture. Mind it that Argo CD is still the first-class citizen. Kargo is not here to replace Argo CD, but it is just on top of Kargo, and it's just another tool that builds into with Kargo so that it can handle all the promotion and all those things. So it basically is making the lives of administrators very much easier, because now you don't have to actually manually go looking for the versions and updates and all those things. It's slotting into there, doing all the stuff with you. So I'll come on top of some of the things about Kargo, some key concepts that will possibly help us to understand Kargo better and how is it fitting into the whole picture. So in Kargo, we have the smallest deployable unit, which is called as freight. Now, what is freight? Freight is the collection of all these artifacts. Now, what do we mean by artifacts here? Is basically your image repositories, or let's say your commits, image updates, or your configuration commits in Git, or say in case of Helm, any of the Helm updates. The collection of all these, or one or many, is in together called as a freight, which is an artifact. And then this artifact is something that will become a Git commit that will be made by Kargo automatically, right? Now, going ahead, how are we storing all these freight? That is where another concept of Kargo comes into picture, which is called the warehouse, which is nothing else but a place where you store all these artifacts, that is all the freights. And this freight gets staged before it gets deployed here. So basically, we will be using this warehouse so that we promote these artifacts from one environment to another. And that is the job of warehouse over here. Next, where is it running? Of course, it's running somewhere in the environment. But in Kargo, we are avoiding to use the word environment because the word environment differ in different teams. The meaning of it differs. So we will instead call our environments, that is production, dev, staging, etc., as stages over here. And stages basically is nothing else but the reflection of the purpose of your application. So why is that code at this particular time deployed in this particular way? So that is the purpose of stage. So stage can be anything from development to staging, testing, and all those kind of stuff. And then another concept that comes into Kargo is subscriptions. Now, very obvious. Now, this is the way for you to determine if the freight that you are building can be promoted to the next stage or the next environment or not. So this is a way for warehouse to use this particular method to decide if the verifications are completed, if the tests are completed, and then if this particular freight can be promoted to the next stage. That's how subscriptions work. Now, these are the fundamental concepts in cargo, freight, stage, warehouses, and subscriptions, using which you can basically automate the promotion of your software delivery. And there is a very good example here. This is very much an analogy you can take where the airline lets you board the plane just because you have been verified by the TSA, right? So it's very much similar to how subscription works in cargo. So overall, this is how cargo works. Basically, a user will apply the changes, build and push the image configurations in Git repository. Now from this Git repository, Kargo is just right there, always detecting the changes in Git repository or the container registry. Like I said, there are 3 ways to detect it: from image updates, from Helm updates, or Git repository. Kargo will detect these changes and simply promote these changes to environment with the help of GitOps. Now this GitOps controller is nothing else but your Argo CD, Flux CD, anything that can sit there. And then it will be able to detect those changes from GitOps repository. And obviously what Argo CD always does, that is applying those changes in the clusters. Now Kargo also does something called as verifying the successful updates of these particular changes using its integration with Datadog, AWS CloudWatch, and Prometheus, and several other, and then repeat these promotions and verifications for any of the downstream environments. So Kargo in this way gives you ultimate visibility of all your environments. Like you can see here, the dev environment, staging, production, anything that you can mention. So all your environments and deploy targets are now at one single place. And you can see what is running, where it is running, and what is safe to deploy, what not. We'll be able to see a quick demo about it as well, of how this works in production exactly. So these are the freights from the freight timeline. If you see, every freight has its own set of information with version updates, the metadata, and of course, this is the warehouse where you are able to store the data, and these are the 2 places where this warehouse is fetching information from. So if I can see clearly, I can't actually. Zoom it in a little bit. Yeah. So this thing is fetching from the GHCR repo, and one is fetching from the GitHub. So once it is fetching the images and the Git repository. This is how warehouse works, where it is subscribed to these 2 freights, and then the freight timelines are created using these warehouses. Sorry, these are the 2 subscriptions, and this is the freight timeline that is coming into the warehouse. And here that you see in the colored form are all the stages. So these are the stages where these freights can be promoted to. Now, if I quickly show you how this is done, that's as simple as drag and drop, where you are able to promote the artifacts into the correct stage. And this will be able to do the next steps. Now, I'll get back to this, but before that, I hope I was able to explain the lineage and the audit and the history that comes across with this. So there is also a history that it maintains right over here in terms of how many freights have been promoted and which had failing pipelines and what was failing, exactly everything over here. So it's the ultimate visibility that you would require, and all of this is open source. So what can be even cool than that? Now, after this, we have testing and verification, like I already mentioned. So let me quickly go back to the slides. Yeah. So Kargo lets you automate the testing and analysis with the help of several integrations that it has: Prometheus, Wavefront, Datadog, AWS CloudWatch, and several others. And it is still developing and adding much more stuff. And we are always inviting open source contributions. So if you have something in mind, you can even add those as well. So these are all user-defined test analysis, and you can use them to verify a deployment. So a quick TLDR, what is Kargo exactly doing? Kargo is focusing on the delivery, basically managing how and when the new versions of the softwares are promoted between several environments, that is dev environment or production or staging in any of those environments, right? Whereas when it comes to Argo CD is more about focusing on the deployments. Now, deployments is what actually is applying the manifest to the Kubernetes cluster so that you can bring it to the desired state. And that is the difference between Kargo and Argo CD, none of which is replacing each other, but is just an extra thing to enhance the feature. So with Kargo, our aim is to basically provide a declarative way, like I already mentioned, to promote our applications in our GitOps workflows and environments. So I think this was very much how we are able to do things. In case of Kargo, I hope I'm not over the time, but yeah, I think I have 4 minutes. So this is how Kargo exactly works. I have showed the freight timeline, and now all of these repositories are linked to one or the other Git repository. So in this case, this is subscribed to a Git repository like you've seen here. And if we go back to this Git repository, we can see how Kargo was able to make commits and create pull requests. One second. Yeah. So in this example, we'll be able to see how Kargo is able to make commits based on these pipelines. So if I go into, say, this particular dev stage, you can see the pipelines are designed over here. These are several this is a promotion template where we define what exactly are the steps that needs to be taken so that a particular artifact can be promoted to the next stage. In this case, which is git clone, git clear, and customize, build, git push, and then create Argo CD. So here, it was able to push these changes, and then Argo CD was updated. So this is a simple promotion pipeline of how Kargo works. And all of this is very much declarative. So if you want to see the freight history of how this is working, you can see it here. And everything is, this is the ultimate view of how Kargo works. Everything is on the dashboard. You can see the manifest using which it was able to do all this. The manifest is very much simple. Yeah, we have a simple kind resource of Kargo, and it was able to do it with the help of these declarations, that is the freight origin and all the information that is stored right over here in the manifest. Yeah, now next thing, this was about the Kargo. These are the production environments. We have more examples of Kargo if I can get through these in the time. Kargo works for Helm charts, and Kargo is now also able to do multi-target. So there can be multiple targets for Kargo. Like you see, you can subscribe to multiple warehouses and promote them through the environment at one dashboard. And there are obviously multiple project support with it. You can also monitor the changes and give admin permissions and all of that at one place, like you can see here. Yeah, so that was about Kargo in a nutshell, but that's definitely not it. Up till now, we've been seeing how Kargo was working with Kubernetes cluster, but in the roadmap, Kargo might also see support for non-Kubernetes configurations. So it comes down to Terraform HCL or any other arbitrary configurations. Kargo will also see promotion plugins. So by that, we mean non-Kubernetes deployments, maybe Lambda, Terraform, or any of the CDNs, and other popular deployment tools like HashiCorp Atlantis. And some of the notifications and hooks which are also not a part of open source yet are like Slack and Jira integration, ServiceNow, and things like that. So these are all in the roadmap of Kargo, and hopefully will be seen soon. And if you want to get involved, if you want to contribute, this is the open source repository for Kargo. And yeah, that was mostly it. If you all have any questions, I would be glad to take it.
Do you have role-based access control to control who can access what parts of pipeline? So to say, for example, differentiate between developers deploying into something like staging versus deploying into pre-prod or prod?
Yeah, absolutely. So I think I can show you that as well. We have added role-based access control into Kargo, and there are several integrations for the same. If I can see clearly, there are settings for the same. You can access all the roles. Wait, let me quickly see it on my tab so I can show you even better. Yes, the answer is yes. If you see there are users here, and you can define the permissions for, like you mentioned, staging, production, and all the different environments, those are all possible with Kargo.
So do you have customers in regulated environments?
Not that I'm aware of, because I do not very much deal with customers, but I think there would definitely be use cases where a customer, where people who are not very much with the technical background do not have to deal with all of these things, and Kargo will do that for them. Yeah. Thank you.
So when you talk of freight, is freight on all freights and warehouses and so forth, are these ultimately CRs that point to different, like does freight, you said it's, there's different types of artifacts like config, images, and other, other components. Is it a CR that points to all those, or do you bundle is freight bundled together as a single kind of OCI artifact, or how does that work?
Yeah, so freight is not actually a custom resource. Freights are created when you mention the subscriptions in the warehouses. So in the warehouses, again, warehouses is a custom resource definition with Kargo, and it subscribes to certain GitOps repository or Helm repository or image repositories and those kind of things. And then freights are created whenever there are changes or version upgrades in these particular repositories. And that's how freights are created. That's what you see here. Freights are not something that you manually create, but are something created as a part of the warehouse configuration.
Yeah, thank you so much for this presentation. I'm very curious to know if you have already seen some security use case with Kargo, specifically, leverage Kargo to do the delivery of OPA policy or Kyverno policy.
Yeah.
If you have any feedback to share about that, I will be very interested to know that.
Yeah, absolutely. So I think when it comes to Kyverno and all the other security considerations, that is something that Kargo needs to handle. It's, I think, very much a thing for any other CD workflow, and not specifically for Kargo, because Kargo is very much the center stage and the mid-tier between CI and CD. So it does not have to directly deal with Kyverno, but Kyverno can always be a part of Kubernetes cluster, which will apply all those policies and several other integrations that can be after it. So we have been in talk with the Kyverno community as well about the same thing, and the conclusion was the same, that it does not have to be a part, but of course it can be something that can be happening after Kargo was able to do its job. So yeah, it's one of the things. And in case of Kargo, the security considerations is specifically coming with managed credentials, and Kargo uses secrets to enhance its security and several other ways that it has out there.
If I use that to deploy my Kyverno policy, I will be able to generate, artifact and also testing about the deployment, right?
Yeah, so I mean, Kyverno is basically something that is more like a policy engine that works on top of Kubernetes clusters, right? So that would possibly come into picture when Argo CD is about to deploy those things.
Okay.
Yeah, Kargo is more about promoting your artifacts from stages.
Okay, perfect. I understand now. Thank you.
Yeah, thank you.
And we have a little break now.
Thank you so much.
See you later again here for some awesome AI talks, so please join.
Thank you so much.